Hi, my dear class 10th Telangana warriors. In your class 10 physics, based on light concept, you have three lessons. And our first lesson is reflection of light by curved surfaces. Based on light concept, you have one more lesson, that is refraction of light by curved surfaces. If you learn the images found by convex lens here clearly, then your next lesson in human eye and colorful world, you can easily understand structure of eye and its function. So this is how one lesson is related to another lesson, and these are the three lessons based on single concept, that is light. So let us quickly start with our lesson 1, reflection of light by curved surfaces. As part of our Fatafat Dhanadhan session, let us discuss very important topics of this lesson, and let us look at those topics. See here on the screen, rules to draw ray diagrams. Then ray diagrams of images found by concave mirrors. Third, characteristics of images found by concave mirrors. Then fourth, curved mirror formula, magnification formula. Based on that, we are going to solve some problems. So these are the important topics which we are going to discuss as part of our Fatafat Dhanadhan session. So let us discuss rules to draw ray diagrams related to concave mirror. See here on the screen, this is the concave mirror and this is the principal axis. If an incident ray which is parallel to principal axis and coming and hitting, incidenting on the concave mirror, what happens? Does it go and sleep? అది ఎక్కడికి వెళ్ళి పడుకుంటుందా? No, అది పడుకోదు. It bounces back. So when it is bouncing back, what happens? Question is, when it is bouncing back, what happens? It passes through this focal point. See clearly on the screen, the incident ray which is parallel to principal axis, while reflecting back, the reflected ray passes through focal point. This is the rule 1, and this rule will help you to draw ray diagrams. Let us now look at second rule. See here on the screen, rule 2, and in this rule 2 you can see incident ray itself is passing through focal point. If incident ray is passing through focal point, then again what happens? ఇది అక్కడికి వెళ్ళి పడుకుంటుందా? No, it also bounces back. Now when it is bouncing back, how does it bounces back? See here on the screen, it bounces back and the reflected ray is parallel to the principal axis. I am repeating rule 2. The incident ray which is passing through focal point, its reflected ray will be parallel to the principal axis. So this rule also helps you to draw ray diagrams. Now let us look at another rule, that is rule 3, and in this rule you observe carefully here on the screen. This is the incident ray and it is passing through center of curvature, and this also don't go and sleep, అది కూడా పడుకోదు, it also bounces back. So when it is bouncing back, what happens? The thing is, the reflected ray also passes through the same path but in opposite direction to the incident ray. అంటే ఇన్సిడెంట్ రే డైరెక్షన్ ఏమో ఇటు సైడ్ ఉంది, రిఫ్లెక్టెడ్ రే డైరెక్షన్ ఒకసారి అబ్జర్వ్ చేయండి, ఆపోజిట్ టు ద ఇన్సిడెంట్ రే. పాత్ సేమ్ పాత్ బట్ డైరెక్షన్ ఆఫ్ ద reflected ray is opposite to incident ray. So this is the third rule, and these three rules will help you to draw ray diagrams of images found by concave mirrors. Now let us discuss very important topic, that is ray diagrams of images found by concave mirror. Here you have 1 plus 1 offer. What is that? If you will learn, or if you can learn easily all these ray diagrams, then in lesson 4 also you have ray diagrams. If you are comfortable with these ray diagrams, then you can automatically draw the ray diagrams which are there in lesson 4 also. So that is the reason we can say it is a 1+1 offer. Now let us look at each and every position of the object. Now the object is here, where between P and F. When the object is in between P and F, now to draw the ray diagram, we are going to use, previously we have discussed 3 rules. Out of those 3 rules, we can use any 2 rules. So if we take an incident ray which is parallel to principal axis, what happens? Just now we have discussed. This incident ray which is parallel to principal axis bounces back and passes through this focal point. So its reflected ray passes through the focal point. Let us take one more incident ray which passes through center of curvature. How does it bounces back? It bounces back in the same direction. And if you look at these 2 reflected rays, the gap is increasing. So if you put screen here, they will never converge, these reflected rays will never converge on the screen. But we can imagine there is a chance that behind the mirror they are going to converge. There are chances, probability is there. So behind the mirror there is a chance of forming image, and this kind of image only we will call virtual image. So when the object is here in between P and F, image will be found behind the mirror, and these are the rays or rules we will use to draw ray diagrams. Now let us draw ray diagram when the object is at F. Here you can see candle is at F. So first of all, let us draw an incident ray which is parallel to principal axis. Its reflected ray passes through focal point. One thing. Now we need to draw one more incident ray. So let us take an incident ray which is passing through center of curvature. It also bounces back in the same path but in opposite direction. Now these are the 2 reflected rays. And if you observe these 2 reflected rays, see the distance is decreasing. It means these reflected rays, they are going to converge at somewhere very far away from the mirror, and highly enlarged image is found. So when the object is at F at focal point, image found by concave mirror is highly enlarged and inverted, and also at infinity image will be found. Next, our object is in between F and C, between F and C. So let us draw ray diagrams now. So again we are taking incident ray parallel to principal axis. So its reflected ray passes through focal point. Let us take one more incident ray, and now this incident ray itself is passing through focal point. Can you guess how does it reflect? Excellent. The reflected ray of this incident ray will be parallel to the principal axis. See here on the screen clearly. This is the reflected ray of this incident ray. Now we have 2 reflected rays. This is one thing, this is one thing. So these arrows will help us whether it is a incident ray or reflected ray. If arrow is this side, then they are incident rays. If arrow mark is this side, then they are reflected rays, and these are the 2 reflected rays which are converging here. So image will be formed here. Inverted image of this object will be formed here. This is the object and this is the image. Now the conclusion is, when the object is between F and C, image will be found beyond C, inverted, enlarged. These are the different characteristics of images, and this is how you need to draw ray diagram when object is in between F and C. Now the object is at C, So again let us draw rays. Incident ray parallel to principal axis passes through focal point. one ray we have drawn. One more ray we have to draw. So let us take an incident ray which is passing through focal point, and its reflected ray will be parallel to principal axis. And these are the two reflected rays. And these two reflected rays are converging here. It means image of this object is formed here and it will be inverted. So when the object is at C, its image is also formed at C, same size, inverted, real. So these are the characteristics, and this is how you need to draw ray diagram when object is at C. Next, let us put object beyond C. Object beyond C. Beyond is different from behind. You should not get confused. So when the object is beyond C, let us take an incident ray which is parallel to principal axis. You know very well it also passes through focal point. One ray completed, one rule completed. Let us draw one more incident ray which is passing through focal point, and this also will be parallel to principal axis while reflecting. Now these two reflected rays are converging here. It means image of this object will be formed here in between F and C, and see here clearly what kind of image is formed when the object is beyond C. And this is how you need to draw ray diagram when object is beyond C. Now let us look at the ray diagram when the object is at infinity, means very far away. See here very clearly, one incident ray is parallel to principal axis and its reflected ray is passing through focal point. Let us take one more incident ray from the bottom of this candle, and it will also pass through focal point. And these are the two reflected rays, and these two reflected rays are converging at focal point. So when the object is at infinity, very far away, then image of that object will be formed at focal point, and it is very small point size image. So this is how you need to draw ray diagram when the object is at infinity. Let us now discuss the characteristics of images found by concave mirrors. Here you can see we have a dance master dancing nicely, and he is in between P and F, and this is the image of this particular object. Now we are going to talk about the characteristics of this image. So if you look at the characteristics, this image is enlarged, means bigger than the object, and it is erected, means not inverted, and this image is virtual because it is behind the mirror. You cannot catch this image on the screen. So that is the reason this image is called virtual, and this image is behind the mirror. So these are the four characteristics. What are they? Enlarged, erected, virtual, behind the mirror. These are the four characteristics when the object is between P and F. Next, our dance master is here. Still he is dancing, so you should clap for him because he has a lot of energy. And he is standing at focal point. If object is at focal point, image will be formed very far away. And you have seen that previously in our ray diagrams. So if you look at characteristics, the characteristics of image formed when the object is at F are highly enlarged, inverted, real, and image is formed at infinity. These are the characteristics when the object is at focal point. Now our dance master is here in between F and C. So object is in between F and C, and its image you can see clearly. Here the object is dancing, and the dance master or James Bond 007 is also here. This is the image of our James Bond 007, and if you look at the image, it is bigger than the object. It means it is enlarged. And just look at here, enlarged, inverted, real, and image is beyond C when object is in between F and C. So these are the characteristics when object is in between F and C. Next, our dance master is at C. When the object is at C, you can clearly see object height, image height. Both of them are same. It means same size image is formed and it is inverted. It is real and image is at C. So these are the four characteristics when object is at C. What are they? Same size, inverted, real and image is formed at C. These are the four characteristics when the object is at C. Now our dance master is here where beyond C. So when the object is beyond C, where is the image forming? Between F and C. Is it bigger than the object? No. Image is smaller than the object. It means diminished image. So let us look at the characteristics. What are they? Diminished, inverted, real. Between F and C, the image is forming when the object is beyond C. So these are the four characteristics. I am repeating: diminished, or you can say diminished, inverted, real, and between F and C. These are the four characteristics when the object is beyond C. Now let us look at when the object is at infinity. You can see our dance master is here very far away from the mirror. At that time, the characteristics are image is formed very point size, small size image is formed. And as per the trend, you can say it is inverted image and it is real and image is forming at focal point. So these are the characteristics. Still now we have discussed at 6 different positions when the object is placed. Till now we have discussed these three topics. Now let us discuss curved mirror formula, magnification formula. Based on that, let us solve some problems. So if you look at the formulas, 1 by f is equal to 1 by v plus 1 by u, that is curved mirror formula. And here f stands for focal length, v stands for image distance, u stands for object distance. Next, magnification of mirror formula, if you look at, m is equal to minus v by u is equal to hi by h naught. Here hi stands for height of the image, h naught stands for height of the object. So now based on these two formulas, let us solve some problems. If you look at the first problem, calculate image distance. If an object is placed at 60 centimeters in front of a concave mirror whose focal length is 20 centimeters. Let us note down what they have given in the problem. F focal length 20 centimeters, U object distance 60 centimeters. As per sign convention rules, we should write focal length and object distance with a negative symbol. And the question is, we have to find image distance. V is equal to how much? So using our curved mirror formula, this is our curved mirror formula. 1 by f is equals to 1 by v plus 1 by u. From that you can write 1 by v is equal to 1 by f minus 1 by u. So to calculate image distance, let us substitute f and u values which are given in the question. So here if you see minus into minus plus, you have to write what we have done. In place of f we have written minus 20, in place of u we have written minus 60, and minus into minus plus. Here 20 and 60 is there. LCM of 20 and 60 is 60. 20 into 3 60, that is the reason minus 3 we have written. 60 into 160, so we have written 1. Minus 3 plus 1 will give you minus 2 by 60. From that 1 by v is equals to minus 1 by 30. What do we want? We want image distance. Means reciprocal of this 1 by v we have to take. So from that v is equal to minus 30 we got. From this what we can understand is image distance is 30 centimeters. Since we got negative minus symbol, it is a real image. So this is what the solution for the given question. Now let us look at one more problem. Here, calculate height of the image. If height of the object is 3 centimeters and magnification product is 1.5. So if you note down the given information, h0 object distance 3 centimeters, magnification product m is equals to 1.5. They are asking us to calculate height of the image. So we have to find hi. So for this problem, we are going to use magnification of mirror formula. Here, m is equals to minus v by u is equal to hi by h0. But for our problem, there is no work with this v and u. We have work with this and this. So from this formula, what we are going to take is m is equal to hi by h0. And we want to calculate hi. So we will transpose this h0 towards left. Then hi is equal to m into h0. M value we have 1.5. H0 value we have 3. So you have to substitute m and h0 values. Then you can write hi is equals to 1.5 into 3. When you multiply, you will get 4.5. What is this 4.5? This is the image distance which is asked in the question. Hope you got good clarity on the problems which we have discussed. So, my dear Telangana warriors, as part of our Fatafat Dhanadhan session, we have discussed lesson 1, reflection of light by curved surfaces, and these are the most important topics and questions which we have discussed. Hope you enjoyed. Thanks for watching and learning. Have a nice day.